So to find the surface area of this composite figure or shape, we have to break it down, right? So the surface areas, remember, that's everything that we can touch, right? So it's kind of like the outer part of this cone and the outer part of this hemisphere. What we have to be careful here is we do not want to include the base area or this base circle for both of them because that's sandwiched between both of them, right? So it's like we can't touch that, so we cannot include it as part of our surface area. And so when we're talking about surface area for the cone, we are going to use this surface area formula up here, right? So surface area is equal to lateral area, which is pi RL, plus area of the base, which is pi r squared. But remember, we just said we cannot include the area of this base here, right? And so since we're not going to include, remember, this is lateral area plus area of the base. And so here we are not going to include the area of that base. And instead, we just want this lateral area. So for lateral area, we need slant height, which they gave it to us. And the radius, now they gave us a diameter, but we can simply find the radius by taking half of that, or 4.5. So I have everything that I need to find my surface area for this top cone. So we have surface area is equal to pi, my radius is 4.5, my slant height is 13. And so in my calculator, I'm going to put 4.5 times 13, and I'm going to leave it in terms of pi just so I can work with it a little bit better. So here, my surface area for this cone is going to be 58.5 pi meters squared. Pi meters squared. Okay, and so that's the first part, right? So I have the area for this top part. The second one I got to worry about is now I got to find the surface area for the hemisphere, right? And so there's a little bit more we got to do. So we only have the formula for hemisphere that includes everything, right? Top, this circle here, right? And then everything else that's around it. And so what we're going to have to do is from the surface area of the hemisphere, we are going to have to subtract the area of that base or the area of that circle, which is pretty easy, right? So here, surface area is going to be equal to 3 pi radius squared, so r squared. And then we said we're going to subtract the top circle, which is pi r squared, right? And so we have all the information because really all we need for this one is the radius. And so we have 3 pi radius squared, which is at 4.5 squared, minus pi, and then another 4.5 squared. So we can do it this way, right? Or we can recognize that here we have 3 pi and then 3 pi 4.5 r squared, and then we have pi 4.5 squared. So really what we're doing is 2 times pi times 4.5 squared. Regardless of which way you're doing it, we end up with 40.5 pi meters squared. And so now to get what we call the total surface area, which is the area for everything all put together, we're simply going to add these two areas. And so we get a surface area of 99 pi meters squared. So whenever we're talking about volume, we have to be careful using this one because this is volume for the full sphere, right? And so since we only have half of a sphere, what we do with this formula is we take that and divide it by 2, right? Which is the same thing as saying you're going to multiply by 1/2 because we only want half of a sphere, right? And so how this comes into play, we end up with 2/3 pi radius cubed for volume of a hemisphere, right? Hemisphere just means half of a sphere. So 2/3 pi r cubed is the volume formula that we're going to use. And so the only thing that we're missing here is the height of my cone. And I can find the height by using Pythagorean theorem because my slant height is my quote-unquote C, my hypotenuse. And then h, which is the height of my cone, is what I'm looking for. And I know the radius, which is the base of my triangle. And so the triangle I'm looking at is this, so 4.5. My hypotenuse was 13. H is what I'm looking for. So in the calculator, I'm going to put 13 squared minus 4.5 squared. And that gives me approximately 12.1963, but we're going to use this instead, right? And so to find the volume, we are simply going to add both volumes together, right? The volume of the cone plus the volume of the hemisphere. And so here I'm going to get volume of, starting with volume of the cone, we have 1/3 pi radius, which is 4.5, squared times the height, I'm just going to put that, plus 2/3 pi my radius cubed. So I'm going to put all that in the calculator, and since I want it in terms of pi, I'm putting everything except pi. And I end up with 67.5 pi meters cubed for my volume.